Hello, good morning, everyone, and thank you for joining us at the special ACF and ACT River Basin Drought webinar. My name is Meredith Muth. I work with NOAA's National Integrated Drought Information System program. For over 10 years, starting in 2011, NIDIS, working with many of the partners that are on the call today, including those depicted here on the screen, state partners, federal agencies, stakeholders. We did a monthly webinar series to share with the ACF Basin community what is happening in terms of drought and water across the basin and what should we expect, providing timely information through a very robust partnership. We ended that series, that monthly webinar series, in 2021 once we released the ACF Drought and Water Dashboard, preceded by the ACT Drought and Water Dashboard. And we also started monthly updates via email on current drought conditions in the area. However, once we ended that long-running webinar series, it was recognized by our core partners that there might be a need in the future to hold additional webinars or other communications to the public, to the stakeholders, in terms of drought in the basin as needed. Right now, as many of you know, and probably while you're on, there's been a rapidly expanding and intensifying drought across the Southeast region, including in the ACF and ACT. So today's purpose is to give an update on how we got here, what are the current conditions, and provide a little bit of additional information on what we can look forward to in the future. I want to thank all of our wonderful presenters that you'll be hearing from today, who joined us. I do want to say that we have expanded purposely this ACF Basin webinar to include the ACT as well. So a quick overview of our webinar. We're really fortunate to have David Zierden, the Florida State climatologist, provide the start of an overview of the current drought status, seasonal forecast, and outlooks. We will then receive some brief updates from the states of Alabama and Georgia, and then we'll transition more into water resources with an update on real-time stream flow from USGS, updates on reservoir conditions from the U.S. Army Corps of Engineers, and we'll wrap it up with a winter water resource forecast from the Southeast River Forecast Center. If you have any questions, please enter them into the chat box and we'll get to that at the end. And with that, I am going to go ahead and start by passing this over to David Zierden. Thank you, David.
All right, yeah, thank you very much, Meredith. It's good to be back in the saddle with these ACFs and now the ACT webinars. Although the reason the rapidly intensifying drought is not what we wanted, but it's good to be back in touch with the community and be able to share our information. So with that, we'll go ahead and get started. I'd like to start with kind of an overview of the weather and climate from this summer and the last few months and kind of how we got to where we are today. And we'll start by reviewing the 2023 hurricane season. There are a couple areas of interest in the Atlantic Ocean right now, but none of them pose a threat to this region. And so I think we can mostly close the book on the hurricane season of 2023, which was a complex one. As we went into the season, there were competing factors for the seasonal forecast. There was a early and fairly robust El Nino developing in the Pacific Ocean, which usually means a less active Atlantic hurricane season. However, ocean temperatures, sea surface temperatures of the North Atlantic were running extremely warm, even record warm, which would favor a more active season. So both NOAA and Colorado State University had to weigh both factors, and both institutions kind of split the difference and forecast for an average to maybe a little above average hurricane season. And that seemed to be the right call. So far, we've had 20 named storms, which is a little bit above average, but the 7 hurricanes and 3 major hurricanes are right around the historical average. For our area, Idalia on August 30th was the only landfalling system in the northern Gulf Coast, and it really didn't have much impact to the ACF or ACT basin. Most of the rainfall was further to the east in the Swanee River Valley, as shown in the map of rainfall totals on the lower left. So this was good news and bad news. We didn't have any major impacts in this region from hurricanes or tropical storms, but also Louisiana, Mississippi, portions of the northern Gulf Coast that often rely on tropical moisture for a good portion of their summer rainfall really missed out on that this year. So we'll go ahead to the next slide. And the next big topic from this summer is the extreme heat, both globally and regionally. This is a graph of global average temperature for the summer season, June through August, since 1900. And what we see is the summer of 2023, the global average temperature far exceeded any other summer on record by nearly 0.3 of a degree Celsius. We saw a similar spike in 1998 with the major El Nino then, but we didn't see that summertime spike in 2015. So right now we're really, the global average temperature is unprecedented, both the land temperature and ocean temperatures around the world. And on the next slide, I'll show you what I'm talking about with the North Atlantic sea surface temperatures. Back in February and March, the sea surface temperatures of the North Atlantic, basically from 0 to 60 degrees north, were running at record levels. And as we got into July and August, it was well above normal, well above any other previous summer, the sea surface temperatures, and a full 3.5 standard deviations above normal, which is very exceptional. And these very warm sea surface temperatures continued through August and into September, and really provided fuel for an above average hurricane season. On the next slide, we'll look at regional high temperatures over the summer. And over on the left is just a composite of 500 millibar heights for the summer season, June through August. And what we see is a really accentuated ridging or high pressure over Texas and the Northwest Gulf. At the surface, that high pressure really exerted influence all the way across the Gulf of Mexico and the peninsula of Florida. And it brought extremely dry and hot weather throughout our summer season, especially the months of June and the first half of July. And over on the right is the historical rankings by station of summertime temperatures this summer. And we see all the number ones from the Texas coast through Louisiana, Mississippi, the Florida Panhandle, and the peninsula of Florida. Actually, the state of Florida, it was only the second warmest summer on record because June was a little cooler. However, the statewide average temperature set a new record in July at 84.2 degrees Fahrenheit. And then we crushed that record in August at a full 85 degrees Fahrenheit average temperature for the state of Florida. So that's what we've looked at as far as high temperatures being very persistent all summer long. More relief as you go inland in Georgia and Alabama and the majority of the basins, but the coastal areas really did suffer from these high temperatures. And on the next slide, we'll show that still continues, and it didn't just start in the summer. This is the year-to-date temperature ranks for this region, and we see much of the peninsula of Florida, the Panhandle, South Alabama, South Mississippi, all experiencing their warmest year-to-date temperatures on record. And it wasn't just the land temperatures that were affected, it was also the coastal waters and the Gulf of Mexico temperatures. Here's a snapshot from the first week of July of sea surface temperatures in the Gulf of Mexico. You see they're all very warm, 30 degrees Celsius or more. But what really sticks out is the coastal temperatures of Southwest Florida, the Florida Keys, and even portions of the Big Bend which spent weeks at a time at 90 degrees Fahrenheit or above, causing tremendous problems. The worst coral bleaching event on record in the Florida Keys is easing up now, but a lot of damage was done during the summer. Shellfish aquaculture in the Big Bend and the Cedar Key area, very high mortality from these high coastal water temperatures and low dissolved oxygen. So, and these high sea surface temperatures of the Gulf of Mexico also provided fuel for Hurricane Idalia that underwent rapid intensification as it approached landfall in the Florida Big Bend. So we'll go to the next slide, and we'll talk about the current drought situation. And over on the left is the current U.S. drought monitor from last week. I wanted to show the entire U.S. map to show just how dire the situation is in Louisiana and Mississippi, where they've been at D4 or the most extreme or exceptional drought for several weeks now, and really having a hard time. We've heard on the news of very low flows on the Mississippi River, problems with navigation and saltwater intrusion. And then in the last 4 to 6 weeks, that drought has been moving eastward and now affecting much of Alabama, northwest Georgia, and the Florida Panhandle, as we see with much of those areas in D3 or extreme drought, and even a pocket of exceptional drought in the southern Appalachians. So this is all developed in the last 4 to 6 weeks. As we see on the right, back at the first week of September, very little drought across the 3 states and the 2 river basins. Some moderate drought in the Florida Panhandle and South Alabama, but certainly not the situation that we have today. So we'll go to the next slide. And how did we get there? Well, we've seen a string of consecutive days without rainfall prior to just the last couple days with this Gulf low pressure system. This is the number of consecutive days without rainfall across the region, from 32 in Gainesville and Tallahassee, 28 in Mobile and Pensacola, 20s throughout much of Georgia and Alabama. So it's when we have these streaks, especially with sandy soils without rainfall, flash drought can initiate very quickly. And we'll go to the next slide and kind of explore that further. In the fall of the year, flash drought in recent years is not uncommon. We've experienced it in 2016, where we went 30 to or 40 to 50 days without rainfall. 2019, again this time of year, 2022. And this map over on the left shows that for much of Alabama, western Georgia, and the 2 river basins, September and October are the driest months of the year. So just the normal climatology contributes to this onset of flash drought at this time of year. So we'll go to the next slide, and we'll start looking at the state of the Pacific Ocean and the current El Nino. These are the sea surface temperature anomalies or departures from normal over the last week. And you see the broad area from the coast of South America along the equator all the way to the international date line, very much warmer than normal. Down at the bottom graph is our Nino 3.4 index, where we track this. And we see it was back in late May, early June, when we crossed that half-degree threshold, which defines El Nino conditions, and has continued to strengthen up until this current time. And so right now we're at over 1.5 degrees above normal in this region, which is certainly in the moderate El Nino range, approaching strong El Nino range at 2 degrees Celsius above normal. So we'll go to the next slide. Just to review the typical El Nino impacts that affect our weather and climate patterns during the cold weather months, basically mid-October or November through March. And on the top graph is kind of the conceptual model that El Nino leads to a strengthened and energized subtropical jet stream, and storm tracks excess rainfall and storminess along the southern tier of the United States, the northern Gulf Coast, and the peninsula of Florida. And we start seeing the impacts. These bottom two maps show rainfall departures from normal in October and November, just from all the historical El Ninos put together. And you can see the rainfall starts in October, mostly to our west, but then spreads east and intensifies during the month of November. So with this in mind, and looking at past El Ninos back to 2000 or even earlier, in my estimation, this pattern and the excess rainfall and storminess are already late this year, especially with that 30 or more days, consecutive days without rainfall. So we're a little late. I know it's been a huge problem for agriculture in the area. When El Nino is forecast or in place in the Pacific Ocean, if the rains start too early, it interferes with harvest and getting equipment into the field, and the quality of row crops like cotton, peanut, corn can deteriorate with too much moisture and rainfall. If it starts late like this year, then you have problems digging peanuts with the hard ground. You have problems establishing winter pasture and cover crops that are like to be planted in the fall and the October-November timeframe. So that's what we're seeing this year. So we'll go to the next slide. The forecast is very strong for El Nino conditions to continue through the winter and into the spring months. What this graph doesn't show is there is a 55% chance that this El Nino will mature into a strong event. But meanwhile, it's almost a slam dunk that El Nino conditions will continue into the February, March, April, and March, April, May seasons this spring. So we'll go to the next slide. I talked about the El Nino pattern being late. We thought it was starting to set in back in October 11th, 12th. A very vigorous Gulf low pressure system passed through the area. Excessive rain in the middle ACF basin, central Georgia, central Alabama, and along the Panhandle, Florida Panhandle coast. And it also brought severe weather, and over 24 tornado warnings were issued in central and north central Florida. Several confirmed tornadoes up to EF2 strengths. So this looked like a typical El Nino storm. However, then the pattern switched. High pressure dominated over the central and eastern United States, leading to this dry spell. The next slide, we'll take a look at what's going on currently. We do have a vigorous Gulf low pressure system that's been affecting our area the last couple of days. And over on the left is 250 millibar Heights that does show a very active and energized subtropical jet, which is what we'd expect with this El Nino stormy pattern. And over on the right is the 7-day quantitative precipitation forecast. This was actually for yesterday. That shows heavy rainfall forecast for the Florida Panhandle, South Alabama, but not as much, only fractions of an inch in the middle and upper ACF and ACT basins. So the next slide is kind of what's happening this morning. Here's a satellite image of this vigorous Gulf low pressure system and the rainfall affecting the Florida Panhandle. And over on the right are the rainfall totals from yesterday. We see the highlight is 1.59 inches at Pensacola. But as we get inland into Georgia and Alabama, only fractions of an inch of rainfall or no rainfall at all in the upper basins. So that's kind of what we're looking at. Is nice relief for the coastal areas, but really not much for the inland and middle and upper basins. So we'll go to the next slide with El Nino in place. This is the official Climate Prediction Center outlooks for the next 3 months, November through January. With the increased cloudiness and storminess, we're just at equal chances of above or below normal temperature. But over on the right is the rainfall forecast, and you can clearly see the typical El Nino pattern reflected here with much above normal chances for enhanced rainfall across the region, especially lower Alabama, lower Georgia, Peninsula Florida, and north central Florida. So with that forecast in mind, we'll go to the next slide, and this is the seasonal drought outlook. And you see over most of the region, the northern Gulf Coast, Louisiana and Mississippi, which are the most drought-stricken regions right now. Drought is forecast to either be eliminated or remain but improved. So that's very reflective of this El Nino forecast. So with that, we'll go ahead and summarize. We've had a near to above normal hurricane season, no real impacts to the ACF or ACT basin other than the lack of tropical rainfall. Record heat globally, the world's oceans, and regionally this summer. High temperatures and lack of rainfall leading to the most extreme level of drought in Louisiana and Mississippi. Drought conditions have spread eastward into much of Alabama and even Georgia and the Florida Panhandle in the last 4 to 6 weeks. And flash drought up to 32 consecutive rain-free days in North Florida, much of Alabama and Georgia. This El Nino did emerge very early this summer and is more than likely to grow into a strong event. The typical pattern of excess rainfall and storminess associated with El Nino, I could consider it late this year, but it does look like we are in a pattern change now, and we'll see a more active subtropical jet and more chances of rain and storminess. And the CPC forecast echoes that, heavily favors above normal rainfall this winter, and drought is likely to improve.
Thank you so much, David. I'm going to now pass it over for some state perspectives, starting with Alabama. We're going to have Michael Harper and Lee Ellenberg present on behalf of Tom Littlepage. Thank you, Michael.
Thank you, Meredith. As David pointed out with the drought monitor discussion a few minutes ago, a lot of color for the state of Alabama. D3, D4 are taking hold. Fully anticipate to see a lot of expansion with this week's drought monitor map due to no rain in the past week as well. Go to the next slide, please. As a result of our last drought meeting that we had with the state of Alabama, this declaration was released on November the 8th, and it's showing, much like the drought monitor, a warning status for a large portion of the state, especially the ACT basin as part of that. Go to the next slide, please. So as part of this, we are still meeting monthly with the monitoring and impact group of the state. Our next meeting is going to be December 12th at 1 o'clock. It is a virtual meeting, and if anyone would like to participate, you can either contact me directly, get with Meredith and she can get with me, or you can go to the Alabama Secretary of State's website and get the information there as well. Now, I'm going to turn things over to Lee Ellenberg with the State Climatologist Office and let him talk about a little bit about Alabama's fall 2023 drought conditions.
Thanks, Michael. And yeah, I think a lot of what I'll be talking about is very similar to what David went through, so I'll be quick. Again, after a relatively probably normal to slightly wet summer, dry conditions really started to ramp up in late July with the extreme temperatures. By August 15th, we had our first D2 in the southern region. This quickly ramped up to a D3 within a month by September 12th. We saw this time of year, above normal temperatures, just like David mentioned. Lack of rainfall really persisted across the southern part of the state. So by October 10th, we had really coverage all over the state with the most intense areas in South Alabama. And then over the past month, there has been some relief towards the southern side, but we've had a rapid intensification of conditions in North Alabama with the coverage of our D3 extreme drought increasing from 6% to almost 40% over the course of 1 month, showing that at the bottom from October 10th to November 7th. So we're seeing persistent conditions that are slowly improving along the south and rapidly intensifying conditions with the lack of rainfall in the north, which includes the northern part of the ACT and the ACF. Next slide. I've had a lot of questions from farmers and other folks of what this looks like compared to some of the recent droughts we've had this time of year. And this is a slide just looking at the percent of area in Alabama over time with the percent of area covered by different drought categories. So the top is 2016, which is a very notable drought. The middle is 2019, also a notable, and then the bottom is where we are currently. And you can see that the rapid intensification, I think, is a bit more similar to the 2019 drought. However, the level of dryness is approaching that of 2016. And as Michael mentioned, I think we'll see some of that expand going forward. So this is just a perspective to show kind of where we are in some past analog events. Next slide. And again, as David mentioned, you know, this time of year we are very susceptible to flash droughts as we enter our dry season. This is an image from that we created looking at all the drought monitors designations for the past 22 years, showing at how often during this autumn season, September through November, we have a 2-category increase or degradation in drought monitor designations over a 4-week period. Again, just showing, you know, more often than not, actually, in the basins of the ACT and ACF, we do have these 2-category quickly increasing drought conditions, again, due to the September, October being our driest months of the year in general. And so without that tropical moisture, sandy soils, we can dry out really quickly. And it's something that we're susceptible to this time of year. Next slide. In terms of agriculture around the state, you know, as of October 30th, most of the corn has been finished harvesting, and a lot of the cotton is and peanuts are on the way. Now that we have a pretty good picture of some of the harvest, we can see where some of the damage was most intense, and that was in the peanuts. Again, kind of as David mentioned, in terms of the dry weather, increasing the need to harvest, and then the lack of being able to dig in the ground from hard conditions. The latest forecasts show peanut harvest will be the lowest since 2010 for the state. And then the continuing impacts are still felt by cattle producers. Many producers are still buying supplemental hay as pasture conditions, especially in West and North Alabama, continue to plummet. This is another perspective map looking at the percent of top soil moisture in the bottom right, where you can we're showing just how rapidly increasing the soil moisture is across the state from around the August-September timeframe. Again, looking really similar to what we saw in 2019 as well as 2016. So again, it's that time of year, and we're starting to feel it in terms of agriculture as well as forest fires. Next slide. This is very similar to what David presented as well. We looked at the El Niños that had around the same initiated time, an early El Nino for these certain years. And so again, we're expecting a above average as the pattern has shifted along the Gulf towards South Alabama. However, in North Alabama, in the upper parts of the basin, I think the signal is a bit more mixed, just because we're a bit closer to that Ohio Valley signal where it does get dry during El Niños. And so if it's anything, I think this is again, this is just based off the composite precipitation anomalies from these selected analogs, but kind of what we're expecting going forward. So as we prepare the big meetings and continue our analysis, we'll continue to look at this. Next slide. I think that's it. Thanks.
Great. Thank you so much to Michael and Lee. I will now pass it over to Wei from the Georgia Environmental Protection Division.
Thank you, Meredith. Do I have a way of sort of sharing my screen, or otherwise I can just talk with some narratives?
I think at this point, narratives might be best, and I will make sure that I share in the webinar recap any type of visualizations or links that you mentioned.
Okay, wonderful, wonderful. Thank you so much. So the way we monitor the drought conditions is we do this on a monthly basis. Every month there is a report, and thanks to the federal agencies collecting all the data, USGS and the Army Corps, National Weather Service. And so we use that information in our report, and in the report we summarize precipitation conditions 3-month, 6-month, and 12-month, and we compare that with the historical norms. And then that will be a summary on the short-term to mid-term to longer-term precipitation conditions. And then we move on to soil conditions across the state, basically on a county-by-county level. And that is summarized in the report as well. We then look for 34 active long-term and real-time USGS stream gauges for monitoring. And for this month's report, we have 2 out of the 34 gauges that are showing monthly flow levels that are between the 5th percentile and the record low. We have another 3 showing conditions between the 10th percentile and the 5th percentile. So those are the drier conditions. Then we also monitor 17 USGS groundwater wells. And for this month, we have 1 groundwater well that is showing a level between the 5th percentile and the record low. We have another one that has a condition between the 10th percentile and the 5th percentile. And then we also compile reservoir conditions of the ACT reservoirs, the ACF reservoirs, but also the Savannah Basin federal reservoirs as well. We all know that Lake Lanier is now in zone 3, and the ACF composite storage is in zone 2. The ACT federal reservoirs, Allatoona and Carter's, are in better conditions. We then move on to the federal agencies' projected conditions, and we are relieved to know that it's a consensus at this point that the federal agencies are projecting higher than normal precipitations for the winter season. And we look forward to that improvement. All of these the compilation of all of these conditions are within our drought management website. So anybody's interested, you can just Google Georgia EPD drought management, and it'll take you straight to the EPD drought management website, and you will be able to see all of the drought monitoring reports. That's it, Meredith. Thank you.
Thank you so much, Wei. And again, a reminder, if you have questions for any of our speakers today, please enter them into the question box and we'll get to those at the end. I will now like to pass it over to Paul Ankhorn from the U.S. Geological Service to talk about hydrologic conditions and real-time stream flow. Paul.
Thanks, Meredith. Yeah, good morning, everyone. I'd like to start out by just showing sort of a regional snapshot. So this graph or map on the left is showing real-time USGS network across the southeast here. So the conditions are color-coded based on the historical mean for that day. So you can see throughout Alabama, North Georgia, and a lot of South Carolina and North Carolina, currently running in the low to much below normal range, as indicated by the red colored dots, and then that moves to below normal in the yellow, and then green showing normal. And roughly 65% or so of streams in Georgia currently are in the normal condition. And then blue are the higher flows that we're not seeing pretty much across the whole southeast there. The map on the right, and I'll specifically be talking about the ACF basin in my presentation today, but we're seeing real-time stream flow conditions in the ACF. This is pulled from the drought dashboard, which I encourage you guys to use if you're not. But you can see roughly 57% of the streams in the basin are currently in the normal flow condition compared to historical ranking. And then you also see the drought monitor is overlaid as a layer there. So that's pointing out where the drought is and where the low flows are. Next slide, please. Here we're showing the below normal 7-day average stream flow. So the top map was actually pulled from one of our last presentations. And I just kind of wanted to highlight that the western part of the country has really eased as far as drought conditions go. However, that has sort of moved further eastward, and I wanted to point out two areas in Georgia, the southwest and the northeast, which are currently showing as severe hydrologic drought as compared to the normal 7-day average stream flow. Next slide. So we're going to dive into the drought dashboard here. So we're showing the 28-day average stream flow. So this is a composite of the previous 28 days, and it's more of a long-term statistic designed to filter out some of the variability from day to day. So this is more of a robust characterization of the flows. So you can see right now we have about 2% in the ACF basin showing low flow, 14% much below, 48% below normal, and then 36% of gauges are currently in the normal range. And again, 0% any above or much above flows. So we're not seeing any high flow, obviously. Let's look at the next slide. And using this as a launch pad here, I wanted to look at Lake Lanier inflows and show you guys what we are currently showing as inflow into Lake Lanier. So we'll look first at the Chattahoochee River near Cornelia. So we will click on that link there and go to the next page. And so we will land on the real-time stream flow, which is the graph on the left. And so the blue line shows our current condition there. So as of yesterday, Cornelia was showing 241 CFS. By way of comparison, this time last year, we were at 379. And both of those values are actually below the long-term median. That's 420 CFS. On the graphic on the right is the 28-day average flow, and that's the black line there. And you can see that it has moved into the much below normal category there for this time of year. Next slide. So this is Dahlonega, another major tributary to Lanier. And so current conditions there are 81.5 CFS. Again, this time last year, we were at 152 CFS, the long-term median of 177. So we're at about 50% of the long-term median there. So you can see that in the 28-day average. The average now has just crossed into the 5th percentile. Next slide. So we'll move down the basin down through Atlanta. So this is Chattahoochee River at Atlanta, which is currently showing the 28-day average to be in the below normal. And then Chattahoochee at Whitesburg is approaching the much below normal. So it's right at around the 20th percentile. Next slide. Further downstream, Chattahoochee at West Point, the 28-day average has just crossed the threshold of a new extreme. And Chattahoochee at Columbus is approaching the 10th percentile, the 28-day average. Next slide, we'll move over and start taking a look at the Flint River Basin. So again, as of yesterday, we're showing 94.5 CFS. A year ago today, it was 118 with a long-term median of 108. So we're in the normal range there. We're pretty close to that long-term median. And then that shows in the 28-day average, we are just around the 22nd percentile in the below normal. What I wanted to point out too, and I'm sorry I missed this, looking at the 28-day average, particularly with the Lake Lanier inflows, you can see we typically expect an uptick in flow, as David was talking about. We're sort of late in the season here. And that was really evident in the Lake Lanier inflows. We're about 3 or 4 weeks past that uptick. We expect flows to increase. And you can see that here with the Griffin plot. But also another note, in these past 2 years, we really haven't seen any major events in the normal to much above normal range. The 28-day average flow for majority of the year in all of the sites I've shown pretty much hung in the normal range. So we didn't really see any major recharge events in 2023. Okay, next slide. So we're just gonna take a quick tour down the Flint River here. So in Albany, we're right at the 25th percentile. And the gauge at Bainbridge is showing that we've just crossed into the below normal for the 28-day average. All right, and then the last slide. This is the Apalachicola River, and this is our most downstream gauge that we present to Blounston. And we have just crossed into the 10th percentile flow there for the 28-day average. All right, last slide, I think I'll just wrap up. And that covers it. Thank you.
Great, thanks, Paul, so much. We'll now pass it over to the U.S. Army Corps of Engineers Mobile District, where we'll have both Bree and Jody talk about the ACF and ACT, starting with the ACF. Thank you.
Hey, thank you so much. This is Bree. I'm the current ACF Basin Manager. Starting with Lake Lanier, we are currently in Zone 3. As Mr. Paul stated, we really haven't had any major recharge events this year. So we are below the historic median represented by the orange line there. Much of the preset that the ACF has seen has fallen below Lake Lanier. So the only thing that would really help us out at this point is to have a rain event directly on the project. But for now, it is forecasted to slowly keep declining. Next slide, please. For West Point, we are in Zone 1, and if the inflows hold steady, it is forecasted that we may actually reach the top of conservation. Generation is currently taking place just in order to balance out the rest of the lower ACF and to keep the elevations between the lower ACF balanced in the system. Next slide, please. Walter F. George is in Zone 2 and is forecasted to remain within Zone 2. Generation is taking place at George in order to keep Lake Seminole at an appropriate operating level whenever the Flint River is not contributing enough into the project. So we like to keep this at a pretty steady elevation as a backup for Lake Seminole. Next slide, please. And Jim Woodruff, at this time, we are releasing our basin inflows above 5,000 CFS and maintaining a healthy operating level. This 5,000 minimum discharge is in order to meet our downstream flow requirements. So we are trying to keep a relative elevation around that 76.5 zone shown there. And next slide, please. This is our composite conservation and flood storage for the entire ACF. As you can see, we are in composite zone 2 with a slow and steady decline towards the end, but we are forecasted to remain within composite zone 2 throughout the rest of 2023. Next slide, please. And this is the ACF summary, restating what I just presented. Thank you.
Alrighty, this is Jody with the Corps of Engineers. I'm currently the ACT Basin Manager. We'll start at the headwaters with Allatoona. Allatoona's been pretty good this year. We've either been above the median and hitting top of conservation. At the moment, we are riding the median going into our winter pool levels. I expect us to be at least slightly above the median and possibly hit top of conservation towards the middle to end of December. Next slide, please. With Carter's, we are still in zone 1, so we are generating as much as we can. We're pumping back as much as we can to meet the energy demands that SEPA has. We are currently riding right below the median during this time. We've had a couple wet years these past couple of years, so SEPA's been really happy, but as of right now, we're still doing fine and dandy there in zone 1. Our current discharges from the Carter's re-reg is 350 CFS as indicated by the bar chart on the bottom right. We'll continue discharging that for the remaining time until we see more water. Next slide, please. So these are actually some new products that we have on our webpage for the Alabama River. We have forecasted pool elevations for RF Henry, Miller's Ferry, and Claiborne. So with RF Henry, we are within our operating pool between 125 and 126. Next slide, please. For Miller's Ferry, same thing. We are between our normal operating pool range between 80 and 81 feet. These are run-of-the-river projects, so we are just essentially passing the inflows that we are getting from Alabama Power. Next slide. For Claiborne, we've added a couple things here, tracking the target flow that we have downstream of Claiborne. That is the 6,600 CFS flow target, which correlates to a 7.34 feet of tailwater. We also have indicated the full navigation depth and the adjusted navigation depth for the current navigation profile. We are currently dredging below Claiborne, so these numbers will change as soon as we get the updated numbers from navigation. Next slide, please. Overall, all the projects are currently in zone 1 on the ACT and or within the operational headwater pool elevation ranges. We're currently meeting all downstream minimum flow requirements at the headwaters, and we are currently meeting the downstream target flow at Claiborne for the past 3 weeks. We're forecasting to stay within zone 1 at the headwater projects for the next 5 weeks. If you guys have any questions, feel free to reach out to us via email. We're more than happy to go ahead and explain any things that are not clear. Thank you.
That was wonderful. Thank you so much, Jody and Bree. And now our final speaker, we'll pass it over to Todd at the Southeast River Forecast Center to talk about a forecast for water in the region. Thank you, Todd.
Thank you, Meredith. Thank you, Meredith. And we can go ahead and go on to the next slide. And so what we're going to talk about here, as we start to approach the El Nino recharge season, we looked back to the past to look to moderate to strong El Ninos and look for stream flow analogs throughout the whole Southeast. So if we've got areas that are just outside the ACT or the ACF, we can kind of look at those. And when we look at now, remember that as we look at the past, there are only so many events that we can look at. So this is a small group of, not a huge group, but a small group of years that we can use for all of this. And so when you look at the November, the green will indicate that during those months, during that month in an El Nino year, that we were above normal. And then the yellow indicates that it is near normal, and the red indicates below normal. So we have had years where we have been below normal in some of those cases in the ACT and the ACF. We see a similar thing in December. We have had years where we were dry. It's kind of been even. So it's not unusual for us to have this. And again, as David mentioned before earlier, is that we've come out of a dry season, and if we don't get tropical moisture, if we don't then we typically are very dry during that time period, and that's exactly what happened this year. So we're going into this all with being very dry, so that will keep us from getting wet for a little bit longer. Even when we get rain, our stream flows will probably remain low. So as we look at December also, where also we have, equal chances in a lot of those for above normal, near normal, and below normal. But as we move into January, and the next slide, we start to see that shift just a little bit. We start to see a bigger piece of the pie being above normal or near normal, with just a few below normal. And that goes across much of the Southeast, not just the ACT and ACF, but over much of the Southeast, and very much more so as we look at February, where we have a lot of those areas showing much above normal or near normal. And so we'll go to March, which gets us through which is the next slide, and that'll get us to the next, the end of the season, the end of the winter season. And you can see that over much of the Southeast, we're above normal. So that's why right now we have a lot of confidence that we, even though we're in a drought now, even though we're very dry, our streams are low, our reservoirs are low, that our recharge season should be pretty darn productive. And so that's just kind of an overall looking at those things. So we're going to look at one particular year. Let's go to the next slide. And it's an analog, kind of very similar to what we're seeing this year. So one of the things is we look at the ENSO, so that we're in an El Nino right now, and then we have something called the Pacific Decadal Oscillation, and that's the PDO, and we're negative. And it's oftentimes that those match up together. They're both positive. This year, it's unusual. We have a positive ENSO and a negative PDO. So we tried to look back to the past to see what years maybe this happened, and we have one year that we could look at. So thank you to the USGS for all this great data that we can look at. And when we look at this, and on the right-hand side shows the current, where we are right now, and how over the whole Southeast, we're pretty dry. Well, if we go back to 1973 and we had a very similar look in that, we were very dry at that time too, and we're staying dry. And sure enough, during that time, during that November and into January timeframe, we got very, very wet. And so it's, again, we don't have very many of these cases to look at, but this is one of them we're able to look at. So that means there's still that opportunity to see wet weather and to see it getting wet during that time. So let's go ahead and go to the next slide. And so as you look at this, and this goes back to the 72 and 73 as compared to all the rest of the El Ninos. And so the blue shows the 72, 73 year. And you can see we were very dry, more dry than we had been in El Nino years up until that December timeframe. Each of the months was a little bit drier. And then in regular El Nino years, but moderate to strong El Nino years, we were a little wetter as we got through the fall, but we were dry. But in that 72 to 73 year, we ended up being more wet through a lot of those compared to all the rest of them in general. And so again, it gives us hope that as we move forward, that we won't be seeing any drought. However, the flip side to that is that we're likely to see a great deal of flooding. So that's the flip of this. It's good that we're not going to be at a drought anymore. It's good we'll have water to work with, but the potential for flooding is very high. So let's go ahead and go ahead and click on it, and it should, and the next slide. And so this will show the 72, 73 ACF, and you can see, so on the blue is the ACF, and the lighter blue is the ACT. It's not actually the ACT, it's just the CT part. The Alabama split out because of the way we did the regions. So we get the bottom of the Alabama, but we can see the 100% line. And as we get into the month 12, which is December, that we ended up being above normal for all of those particular periods. And if you click on it, the little red dot will kind of show you how we've gone. Go ahead and click on the, there you go. And you'll see how we've gone up and how through the whole period, all through the winter and into the spring, our stream flows ended up being extremely high during that time. And so, like I said, I think that hopefully this is the only one of these briefings we have to do with respect to drought, because I think that we're starting to turn the corner. As David mentioned, I think we're starting to see a pattern change where we're starting to see those Pacific storms start to move out of there and move across the country, where we'll start to see more rainfall events more often. And I think we'll see them more frequently as we get into December. So with that, let's go to my last slide. So the dry weather pattern looks like it will give way to a more active and wet El Nino pattern. You know, as mentioned before by the Corps, lake levels are now well below normal, or in many cases they are, but are likely to recover as we approach the winter and into the winter and into spring. And the recharge/flood season is expected to be active. It is likely the rivers will recover, and once they do, flooding will become an issue as we approach the rest of the winter and into spring. And if you have any questions, I will be available.
Thank you. We are so fortunate to have so many fantastic storytellers. Todd, David, everyone on this call. Thank you to all our speakers. We've mentioned the drought and water dashboards for the ACF and for the ACT Basin. If you haven't explored it, please do. The links are in the chat and we'll make sure that you see it. This is a great way for you to stay up to date on past, present, and future drought conditions. And it's very interactive. You can download maps, zoom in on your certain areas, etc. Before we leave, I just want to say that we do have time for one question. If you have additional questions, so go ahead and still take a moment, put them in. We'll make sure that we respond to you offline. Reminder that the summary of this webinar and recording will be sent out. Feel free to share it with your networks. If you are interested in learning more about what the El Nino is going to look like in the Southeast and the winter outlook, we are going to have a special presentation on that in the next Southeast Monthly Climate webinar series. We'll make sure that you have a link to register for that. And in addition, if you're also interested in tracking drought and water conditions in the basins, please feel free to join the Southeast Drought Early Warning System. And of course, we'll give you those links as well. When you leave today, there will be a quick post-webinar survey with a couple of questions. We'd love to hear some feedback from you. With that, we have time for one question right now, maybe two if we can. The first one is going to be for the Army Corps. Can you elaborate on the impacts for users or the U.S. Army Corps operations on Lake Lanier being in Zone 3?
Hey, Meredith, James Hathorn. Can you hear me?
I sure can, James.
Okay, all right. So at Lake Lanier, we have what we call recreational impact levels. And there are 3 levels that are identified at Beaufort as well as West Point and Waltef George. The initial impact level is 1066 for Lake Lanier, and the recreation impact level is at 1063. And it reads this: this is the level at which major effects on concessionaries and recreation are observed. All beaches are unusable and dock facilities have more serious problems. So I hope that helps address the question as far as the impacts. That would cover the impacts to the users. Now, as far as the Corps of Engineers, when we enter Zone 3, we're operating much more conservatively. At this point, Beaufort Dam, the releases are only to support water supply and water quality needs to support Metro Atlanta. We're not releasing excess water for generation or to meet downstream flow requirements at the Apalachicola River. Those releases are only to meet the Metro Atlanta water supply and water quality needs. Now, I will say that those releases will benefit the downstream users. It's not like there's no secondary use of the water that we're releasing, but we're operating very conservatively right now. That may have been more what you asked for, but hopefully that answers the question, Meredith.
James, that was perfect. Thank you so much. And it looks like we have time for one more quick question. I'm going to direct this one to Lee right now. This question is in regards to the Chattahoochee River. When do you foresee this river to be at normal flow?
Thanks, Meredith. Yeah, a little bit outside the ACT, but the upper Chattahoochee up in Newton, Alabama, I just looked at it, and the current rainfall is bringing that up into normal conditions. It'll take a bit of time to translate that down to the lower Chott, but we expect things to be on the rise now. So I think in the next couple of weeks with these rainfall amounts and these storms coming through, you'll be able to see that kind of enter the normal condition.
Okay, that's great. We do have a few more questions. I think we're going, because we are at the top of the hour, we'll respond to those offline. Again, thank you all for joining us today. And hopefully we're looking forward to a winter of just enough rain, but not too much. As Todd mentioned, we certainly don't need flooding either. So have a wonderful day, everyone.